Hello everyone, I hope everyone is having a great day. I know I am. It's one day closer to the weekend. It's Thursday. So once we get to Friday, it's almost Saturday and Sunday. So today I will be discussing my lesson on the polynomial remainder and factor theorems and how it would correlate to polynomial division when trying to identify factors of a polynomial, f of x, or trying to find the remainders a quicker and neater way when it's asked in a test question or just in anything that you need to know how to find the remainder without having to go through the long process of dividing a polynomial by another polynomial, either using long division or synthetic division that you guys might be familiar with, and I will go over. It will be a much neater way and quicker, of course. Let me go right ahead and explain to you guys what the polynomial remainder theorem is, and then we will go ahead and start speaking about the factor theorem much later on. So, given that you have the remainder theorem states that if a polynomial f of x is divided by a binomial of the form x minus a, the remainder evaluated as that is f of a. That is that you have the a that's in the binomial, you evaluate that essentially in the polynomial that's being divided, also known as the dividend, and you will call this, obviously, if you already know, this is called the divisor. But once you evaluate that a into that f of x, you will essentially be returned a remainder when dividing that. Like I said, this is a much neater way to explain and understand how to find remainders or how to even find factors, which I will explain later. So the theorem states that it will be of this form: f of x being the dividend equals x minus a being the divisor times the quotient that you will get as a result of that polynomial division plus the f of a, which is your remainder. For here, my ELL learners, I have listed the Spanish translation, which is called El Teorema del Residuo Polinomial. Let's exemplify. Now that we have a basic understanding of what the remainder theorem is, let's go ahead and look at an example of how we can evaluate f of a into a polynomial in division, so we have a much neater and cleaner way, quicker as well, to find the remainders or factors. Find the remainder f of a in the division of 2x to the fourth. So we have a dividend of a quartic form, 2x to the fourth minus x cubed plus 2x squared minus 6. This is being divided by a binomial of the form x minus 2. However, before we start anything, let's talk a little bit about that x minus 2 real quick here on the side. That x minus 2, before we even do anything or evaluate anything of f of a, this must follow something in mathematics that we like to call the zero product property, and find the zero when this is equal to 0. We set x minus 2 equals 0. Solve for x by adding 2 on both sides. Plus 2, remember, whatever you do to the left-hand side, you must do to the right-hand side as well. We have a result that x equals 2. But you take that x equals 2 now, and that is essentially going to be your a. I know it was listed as x, but that 2 that you have there is going to be listed as a equals 2, which you will therefore evaluate in our dividend to find your remainder. So let's go ahead and do that. To find a remainder, we use basic algebraic operations, substituting. You guys obviously know this from pre-algebra and algebra 1. We go ahead and we say 2. Remember, put the 2 there from the a equals 2, or the x equals 2, however you like to call it, whatever's easier for you and however variable you think it's easier to mention. 2, substitute for every time you see an x, 2 to the 4, minus 2 to the third, plus 2 times 2 squared minus 6. Let's follow, please excuse my dear Aunt Sally for everything that we do for all order operations. 2 to the 4th is 16. 2 to the 3rd is 8, so that's minus 8. Plus 2 times 2 to 2 squared. 2 squared is 4 times 2 is 8. And then we have the minus 6. So we already know that 2 times 16 is just 32. So we can go ahead and erase that right here. Yep. 32 minus 8. 32 minus 8, we have 24. Then we have 24 plus 8 is 32. And then we have the 32 minus 6 equals 26. So our grand result here has been that the remainder when dividing 2x to the 4th minus x cubed plus 2x squared minus 6 divided by a binomial of the form x minus a or x minus 2 in this case is 26. We can verify this and check if this is the correct remainder, because I like to verify, Mr. P loves to always verify, by using a method we call synthetic division, where we will be dividing this dividend right here by the divisor and finding out if that is actually the remainder that we get after this has been evaluated. We're going to use the same x. Go ahead and erase this. How do we synthetically divide, guys? To show you a neater and quicker way, very similar to how we did the remainder theorem. This is an easier way. Neater than long division. We have that 2 here. We have my 2 in the box for any Timberlake fans out there. And what we will do is that we will list every single coefficient from the divisor, sorry, not the divisor, dividend, from the dividend in order to divide it. Start with 2. Negative 1, remember when you have this x cubed or x squared or whatever, x to the 4th, what the coefficient, if it has no coefficient, it's always 1. In this case, it's going to be negative 1 because of the negative sign. Plus 2x squared, 2. But we notice that we don't have an x term. We would normally have an x term after that x squared. So since we don't have it in this case, what we would do when we're missing a certain term corresponding the n minus 1 rule, we add 0 to it. 0. And then we add our constant term, which is negative 6. Draw a line for another row of numbers. We're going to drop that 2, drop it like a sound, like Snoop Doggy Dogg. And we're going to go ahead and multiply it diagonally and add a cross. 2 times 2 is 4. Negative 1 plus 4 is 3. 3 times 2 is 6. 2 plus 6 is 8. 8 times 2 is 16. 0 plus 16, obviously 16. Additive identities. 16 plus 2 is 32. Negative 6 plus 32, positive 32, is positive 26. It checked out. We get the same remainder. We always use this process to verify which is the correct remainder, guys. Now, since I've already covered with you guys what the remainder theorem is, we're going to go ahead and speak about the factor theorem, which is just another theorem, really cool theorem that follows from the remainder theorem. Piggybacks from it, actually. Let me erase that. Let's set it up with our next example. I'm going to use for the factor theorem. So the factor theorem states that a polynomial f of x has a factor x minus a if and only if that f of a is 0. So it is only a factor that x minus a if the remainder is 0. Let's go right ahead and explain that a little bit further with an example. Now that I have you guys up here again, we will have x squared plus 11x plus 30 as our next example to show the factor theorem. So, in order to do the factor theorem, what we essentially do is we will have to find, and we're actually going to divide that, guys, by the way. Sorry about that, I forgot that. By x plus 6. And prove that x plus 6 is a factor of that. Essentially do this very easily by synthetic division. We can do the remainder theorem. Let's do synthetic division better. Follows the zero product property. X plus 6 equals 0. Subtract 6 by both sides. Those 6 cancel out. 0 minus 6 is negative 6. X equals negative 6. We will go ahead and start doing the synthetic division. Negative 6 of the terms. 1, coefficient 1, coefficient 11, coefficient 30. So you guys can see this is a little bit faster. A little bit neater, too. Drop that one like it's hot. 1 times negative 6 is negative 6 right here. 11 minus 6, which is just the same thing as 11 plus negative 6. That is positive 5. 5 times negative 6 is negative 30. Boom, checks out. This is 0. We have a remainder of 0, meaning that this is a factor of x squared plus 11x plus 30. Now, how can we verify that, Mr. P? That's really cool and it's really cute and all, but how do we verify that? Well, I'm actually going to resort to an old method that you guys did in Algebra 1, which is called factoring quadratics. Let's look at our factors. X squared plus 11x, original polynomial. Not doing any shading with the algebra, so you guys don't think so. And we're going to factor that. How do you factor quadratics? You guys can remember. We have to find two numbers that multiply to give me 30, positive 30, but also add up to give me positive 11. Anyone have a guess? Nobody? Nobody? Obviously, positive 6, positive 5. 6 times 5 is 30. 6 plus 5 is 11. Really easy, right? We will solve with the zero product property as well, making this equal to 0 to find out what our x's are, or what our zeros are. X plus 6 equals 0. X is going to equal to negative 6. X plus 5 equals 0. X is going to be equal to negative 5. Bingo, we have the correct combination. And not only do we have the correct combination, x equals negative 6. Negative 6 is a factor. This follows that the factor theorem holds. I hope that lesson was actually very clear for you guys, and it was very informative to teach you the remainder of factor theorems and how we can essentially find out factors and find out theorems of different, factors and remainders of different polynomials given this. Anyways, guys, thank you for listening to my lesson and listening to my pop culture jokes, and I'll see you next week.